less. So I can increase the total capacitance per unit area by using more than interconnect layers. So if you use more number of interconnecting layers between the two parallel plates, I can increase the effective area of the capacitor. So some technologies use 5 layer between the parallel plates, so that can give an enhanced capacitance per unit area. So a larger value of capacitance can be fabricated. So instead of increasing the number of interconnects, what one can do is adjust the flux between the layers. So one interconnect layer you use, and if you adjust the flux in such a way that necessary effect can be obtained, that is also good. So either increasing the number of interconnects or using a single interconnect and adjusting the flux, so that you can go for whatever design is applicable to you. So when you have proper spacing, so the coupling will also be there. So the effect of coupling cannot be neglected. Okay. So this is going to be, as a figure, what you see is one practical capacitor where the terminals are labeled as P1 and P2. This, as it can be seen, the top and bottom plates constructed out of the same metal layer, alternative to exploit the lateral flux. So this is an example of a practical capacitor which is fabricated and used in applications. And the parasitic bottom plate capacitance is very much smaller than for an ordinary parallel plate structure, since it uses less area. So compared to normal parallel plate and this modified structure, they say that the parasitic capacitance effect is also very minimal. So parasitic capacitance minimal nale, your high frequency application is going to be completely easy for the capacitance. And also, when you go for conventional parallel plate capacitor, this structure is going to give lesser area. So the device is going to be even more compact. Since the lateral capacitance depends on the perimeter, maximum capacitance is obtained with you are going to use the different layout geometries, and we are going to find how I can maximize the perimeter so that my area is going to be minimized. So my lateral capacitance is increased. So I am focused on maximizing the perimeter and minimizing the area. So for that, I'm going to go for a fractal structure. So fractals are structures which are going to have finite area with infinite perimeter. Fractal antennas are very popular now. Fractal nale area is finite and the perimeter is infinite. So by fabrication technology allows fabrication of fractals. So if you use fractal based capacitors, I can definitely go for structures which will have infinite lateral capacitance. So if I use that, I can increase the capacitance value by 10. So I can fabricate high value capacitance also. One simple alternative is used to MOS capacitance. You know, in MOSFET, you have a capacitance effect at the gate itself, right? So I can use that gate capacitance also for applications whichever is demanded.